Okay, the first thing is we're going to we have to understand what the identity matrix is. Right? The identity matrix. Whoa. Oh, so I know why. Sorry. Boom. There you go. All right. So the identity matrix. I'll give you time to catch up. Something I froze that. The identity matrix is a special matrix. Basically, in the matrix world, it's the number one. All right. So we're going to use it in a way. So I'll just show you what the identity matrix looks like. The identity matrix looks like 1, 0, 0, 1, and they're identity matrices for all square matrices. So this is an identity matrix for a 2x2, for a 3x3, which you will not be doing by hand, by the way, right? So, but I'll just show you one anyway. So now your friends in honors would have to do this. They have to create this identity matrix. And all it is you can probably already see, you're going to do row reduction by hand, and you're gonna get the first variable over here to power 1, and then you're going to eliminate both rows. And then what you would do is you would get the power of variable y, or whatever your second variable is, to power 1, and you'd eliminate the row above and the row below. And then you would get your third variable down in the bottom, power 1, so whatever you had to do to it, and then you would eliminate the other two rows. Right, but you're not doing that. We're not going to do that, but you could see that it's no big deal. You could do it very easily. All right. So, all right. So everyone's caught up writing. So that's the identity matrix. Where was I going with this? So, it's basically like the number one of matrices. So why are we going to do it? So let's think about in the real number system. So let's just say we had an equation, 3x is equal to 9. So this is just me relating prior knowledge to what you do, right? So everyone knows we multiply both sides of that equation through by what number? 1/3. So we would multiply both sides of this equation through by 1/3. And I'll keep it consistent with the way we do matrices. I'm going to put a 1/3 in there. Because of matrices, we're going to slot it in on the left. All right. So when I multiply these multiplicative inverses, 1/3 of 3 is equal to what number? 1, right? I see all your fingers. 1x. So that's the same thing as saying 1x is equal to 3. We never write that, do we? We just write x is equal to 3. But what we've done is we've said 1x. So now if we were in the matrix world and we said some matrix A times some matrix X equaled some matrix B, right? We're not going to actually solve this. I'm just going to set it up for you. Then what we would do is we would say A inverse times A would be equal to what thou doest to the left, thou doest to the right, would be A inverse times B. So do you see how these relate? So I've got this is relating to that's comparing prior knowledge. Your 3 is your A. It's just a matrix, right? So 3x is AX. Then I multiply the left side by the multiplicative inverse of the 3, and I multiplied the multiplicative inverse of A. That gave me 1x. This has given me 1x, but we call 1x I x, and I stands for the identity matrix, which is 1, 0, 0, 1. So that's the same thing as saying 1, 0, 0, 1. And I can't show you right now because I don't have an actual matrix in there, but that's like saying 1. We don't actually write it. We write A inverse B. Okay, so what you need to understand at this moment. you need to understand the identity matrix is basically the number 1. And we will get the identity matrix anytime we multiply any matrix times its inverse, right? That's 1/3 times 3, right? We'll give you I, which is in a 2x2 world is that, right? So that's what you should know right now. But that leads to the question, how am I supposed to find the inverse? Right? So one more time before we move on, because I know it's 7th period, right? So you're struggling to stay awake. So the identity matrix is the number 1 in the matrix world. It is found, like any matrix times its inverse will be the number 1. 1/3 times 3, 1/7 times 3, 3/7 times 7/3. You know, something multiplicative inverse. So now we've got to find the inverse. So our next objective is find inverse of 2x2 matrix. And like the earlier example, your friends would use the 3x3 identity to find the 3x3 inverse, but we're not doing that. So how do you do that? So let's give you a 2x2 matrix. So let's use some common letters that are used as elements in a 2x2. So we read across and then down. So it's A, B, C, D. And if this is matrix A, call it A, then A inverse, I'll pull that off the screen. Then A, well, maybe I could write over here. Then A inverse, I'll try and keep that so you can see it. A inverse would be 1 over the product of the diagonals. So AD minus the product of the other diagonal, BC. It will take a nanosecond and 3 problems to memorize. It's not much more than this. Then you take the matrix and you do some magic on it. You some moving around. So what was up on the top left is now going to move to the bottom right, and what was down here switches up. So the diagonal on the left changes places, the top one. Then the others stay where they are. The B and the C stay where they are, but they change sign. Boom, boom. Okay, so I'll take, by the end of today, you'll have it. What's up? No, would not matter. No. What would be different is if you did 1 over BC minus AD, then you'd get the negative of what you're supposed to get. Yep. Multiplication. So all right. So that's a good question. So he's saying, okay, yeah, you told me yesterday multiplications of matrices is not commutative. Yeah, you're absolutely right. This is not tied up in the matrix. I see where you're going. That's still outside the matrix. That's still the product of the numbers 3 times 2, 2 times 3. Yes, all right, I get it. No, it won't matter. It will not matter. Okay, so let's put some numbers to it. So like we get a little bit more familiar, right? So let's do that so we can see we're still finding the inverse of a matrix, and I'll keep the formula up there. So let's just label matrix B. Matrix B is, just give me some numbers, keep them smallish. Give me some numbers. First one here. 2, 4, 5. I heard a 3. Let's do a, can I do a negative to make it look, just to be, make that a -3. Okay, that'll be a good one because of where it is. So just beware of them. So all right, so the inverse, so So let's do this in a different color. Let's do this in, what colors do I have? Purple. Right, so let's do this. So B inverse will be 1 over, tell me what numbers? 2 times what? 2 times -3, so that'll be -6 minus 4 times 5. So that's going to be 20. And then we switch the places of the 2 and the -3. So -3 jumps up there, 2 jumps down there. 4 stays where it is, but it's negative. And 5 stays where it is, but it's negative. And let's just clean it up a bit. So it's 1 over, what, a -26, -3, -4, -5, and 2. Now, it depends where you go for help. So if you go look in your book for help, or if you go on some web search or something for help, and some people might distribute that in. And so what I mean is some people might say the answer is negative. They might say that's positive 3/26. They might say that is positive 2/13, because 4 and 26 have a common factor of 2. And then, I can keep going with this. 5 over 26, positive, and a negative, that would be a -1 over -13. Yeah, so that'd be a -1 over 13. Right, some people might say that, or you're going to see it. So just be aware that they may have distributed it in, and some people leave it out. Like with a -1/26, people might leave it out because it may. So just beware, right? No big deal though. Just know you're right. So let's catch up with what's going on. We know the identity matrix is the number 1. It's 1, 0, 0, 1. And any matrix times its inverse will be that number 1. Well, we needed to know how to find an inverse now. So now we know how to find the inverse of a 2 by 2. So let's use that for our final objective. So now we're going to solve a system using matrices. All right, so let's give you some numbers here. So we've got 2x plus 2y is equal to 6. -x plus y is equal to 1. So let's turn it into a matrix. So I'm going to create a coefficient matrix. So I'll write these out so we're getting used to the terms. We're going to write out a coefficient matrix. I'm going to have a variable matrix, and I'm going to have a constant matrix. Okay, and they all make sense once I put them out there. So the variable matrix, the coefficient matrix, sorry, I lied. The coefficient matrix is going to be 2, 2, -1, 1. I heard someone, that was good. The variable matrix is going to be x, y. And the constant matrix is going to be 6, 1. So just to kind of put a math point on this, we're basically in A times X is equal to B, right? So we've got this. This is some matrix times some other matrix is equal to some matrix. So A, X, B, right? And we want to get this one by itself. We want to find out what X and Y are. So that means I'm going to need to multiply this by A inverse. 3 times 1/3. What they'll do to the left, do to the right. And the only trick here is you've got to slot it right in on the left. because of the dimensions of, because multiplication of matrices is not commutative. So we're going to have to slot it into the left. So let's do that. So we're going to multiply the left and the right by the inverse. So I'm going to put the inverse in. Will this magic one come out? This one looks better. All right. So I'm going to do magic colors. Right, here we go. So the inverse is going to be 1 over 2 times 1 minus 2 times negative minus negative 1 times 2. So that's minus a negative 2. So I'm using my careful use of parentheses, negative, negative. So that's 1 over the AD minus BC is what I just did. Now I'm going to negate the positions. So I forget now. Where do I put this 2 right here? Bottom right. That must mean I bring the 1 up there. Now what do I do to this 2 right here? I thought I left it, but what happens? Negative, and this one's already negative. Do I just leave it negative? No, you make it opposite of what it is. That's 1. Perfect. Times your other matrix, 2, 2, negative 1, 1, x, y. Now, slot. So what we just did was we just multiplied the inverse right here. So what we've got to do is we've got to slot it in right here and multiply the other side by it. So let's do that. So I'm going to simplify. If you're okay, this is 1/4, right? 2 minus a negative 2. And my inverse is 1, negative 2, 1, 2, times my constant matrix, 6, 1. Okay, before I finish it up, is everyone okay? See where everything came from? Go ahead. The 1/4 I went ahead and combined. So like this is this, right? And I said 2 minus, so 2 plus 2.
Why is it x, y, y?
Say that one more time.
Why is it x, y? Or never mind.
I think I know what you mean. Like you're talking about this. Y is x, x, y. Because this is a matrix X, and this matrix is a 2 by 1. And the elements in the 2 by 1 are x, y. So the big old capital X refers to the matrix X. The matrix X could be a 15 by 15. But it's just 2 by 2 here. All right, so so now let's go in and okay. If I were to make you do this by hand, let's think about it. If I multiply, I'll just change this color of this pen. So this is my regular number, and I multiplied it by its multiplicative inverse. That number's always going to be what number? 1. It's always going to be 1. And since we're multiplying by matrices, these numbers multiplied together are always going to equal 1, 0, 0, 1. Providing you've done it right, but just start doing it, checking the key each time, and it's not going to be hard, I promise you. Multiplied by x, y, and then you won't even have to do this, but I'm going to show you once for the lesson. Now, let's do this. I'm going to remember the associative property works in multiplication of matrices. So what I mean, so that's all the algebra 1 words, but they're really important, right? So I could do 1/4 times this, and then I could do that times that, or I could do this times this, and then multiply that. As long as I do them in the right order, it's fine. I just what time, like from which side to which side. So So I'm going to choose to do the 1/4, and then I'm going to multiply this matrix together. So help me out. I've got to do these big numbers, so I'm going to need some help, right? So I'm going to go across the row and down in the column. So I'm going to go 1 times 6, -2 times 1. And then I'm done with row 1, column 1. Because my product matrix, let's think about this. My first one is a 2 by 2. My second one is a 2 by 1. This shows me my possibility, and this shows me my dimensions in my product matrix. So I'm only going to have 2 rows and 1 column, right? So I'll be done. So let's go ahead. So I'm going to do this and this, and then I'm going to do the second one with that, right? So help me out. So I'm going to do 1 times 6 plus what? So I'm going to do 1 times 6 plus -2 times 1, so it's -2. Then I'm done with row 1, column 1. Now I do row 2, column 1. So I do 1 times 6 plus 2 this time. Now let's clean it all up. Now here's why you don't actually have to write this. So watch this, ready? So I'm going to go, help me out, I'm going to go across in the columns. 1 times x, what is that? X. And then I'm going to add to that 0. So the top element is going to be x. And then when I multiply this row, I'm going to do 0 times x, which is how much? 0 plus y. So it's just going to be xy, right? Because it's 1 times anything is itself, right? So let's go in and do that. So you've just got your xy. So basically, I'm telling you for testing purposes, you're absolutely fine to do this. If you want me to re-demonstrate that later, why it's true. Then let's simplify the next one in one step. So you and I can say 6 minus 2 is 4. 1/4 of 4 is 1. 6 plus 2 is 8. 1/4 of 8, how much is that? 2. So how much is y worth? 1? 2, right? Right in their column, like just right in the rows. Exactly what they are. X is 1, y is 2. Go plug it in and check if you want. Nice and easy. All right, so I'll stop this, and then I'll hand you the practice.